All right, so what we're looking at today is the graph of the exponential function and the graph of the log function. So to start, we better look at what does the graph of 2 to the x look like. And you should see a poster on the side of the room for y equals 2 to the x. And where does that t-chart come from? Well, it's a matter of plugging in some values to figure out what it looks like. You plug in 0, 2 to the 0 is 1, because anything to the 0 power is 1. Plug in 1, you get 2. Plug in 2, 4, 3, 8, 4, 16, and so on. Now this first one is 2 to the x, but it's minus 2. So you're just going to move it down 2. But this is the same t-chart you use for every 2 to the x. So there's my 0 zeros right there. So that means 0, 1 would be right here. Over 1 up 2 would be right there. Over 2 up 4. And over 3 up 8 and so on. So it's basically that picture. Now what is this off to the left? Well, that's because if you plug in negatives, if you get 2 to the negative first power, that makes a fraction 1/2. 2 to the negative 2 power makes 1/4. So all the negative does is it flips the fraction. Or flips that number to make a fraction. So 1/4, then 1/8, then 1/16. And as you recognize, that should make an asymptote. All right? So that's the 2 to the x function. You should know how to translate them left, right, up and down, and so on. Now the log base 2 function, if you guys notice this lower part down here, log base 2 of x is the exact same t-chart as 2 to the x, but it's backwards. Because 2 to the x and log base 2 to the of x are opposites of each other. Sorry, my pen's really sloppy. So this t-chart is exactly the same as this t-chart, but it's just inverted. So it's just the inverse. Instead of 0, 1, it's 1, 0. Instead of 1, 2, it's 2, 1, and 4, 2, and 8, 3, and so on and so forth. So that's how you do the log one. It's the same thing. You go 0, 1. I'm sorry, you don't go 0, 1. You go 1, 0. Sorry, I don't have my graph here. The rest of it anyway. You could do it on yours. You're going to do 1, 0. You're going to do over 2 up 1. You're going to do over 4 up 2, and it'll look like this. And if you notice, you have a vertical asymptote at 0 because it can never cross the y-axis, because you can't have a negative output from a power, which is why that is. But anyway, that's the log base 2 function. It's just the inverse of the 2 to the x. Now, similarly, let's go back up to e to the x. E to the x is the exponential base e. Once again, my x got cut off. Exponential base e, which is 2.71828. Hopefully you learned about that in Algebra 2. So you plug in 0. E to the 0 is 1. You plug in 1. Instead of 2, you get 2.71828. But we just kind of abbreviated or rounded off to 2.7. So 0, 1. 1, comma 2.7. Dot is not working very well with this pen. You plug in 2. So you just got to take e and e to the second power. So if I use my calculator and I press e to the second, it says 7.389056099. Anyway, just call it 7.4. So you go over 2, up 7.4, and you can see it takes off quicker than 2 to the x does. So on that note, let me go over here to Desmos, and I've got y equals 2 to the x graphed right there. Here's y equals e to the x. See how they're very similar? They both cross at 0, 1, but 2 to the x is just a little bit flatter, and e to the x is steeper. So this is e to the x, and see there's my 0, 1. Here's my over, my over 1, there it is. Should be over 1 up 2.718. See, that's that e. 1 comma 2.7 and then so on. Anyway, you guys can use Desmos to help you out with some of these graphs, but make sure you understand the parts of the graph, okay? Continuing on, when I'm doing the natural log. So the natural log is nothing more than the inverse of e to the x. So e to the x and ln of x are opposites of each other. So instead of 0, 1, it's 1, 0, and then 2.7, comma 1, and 7.4, comma 2, and so on and so forth. So ln and e are opposites. Log base 2 and 2 to the x are opposites. Otherwise, you guys should know how to transform those. It's just like this one would be left 2, up 3, and you make this t-chart. 1, 0, 2.7, 1, 7.42, and so on. So that's basically a tutorial, a run through of each of these. You guys should still know domain and range. Remember, domain and range for the exponential function, if it comes down here and never touches the x-axis, that means you do not put a bracket for your domain and range, or for your range particularly. Your range would only have, it would start at 0 and go up to infinity, but it never touches 0, so that's why I'm going to put a parentheses. Domain is pretty simple. It can be anything, negative infinity to infinity. Okay, but that's not the domain and range for this problem. This problem is dropped down 2, remember? So that changes my range by 2. Changes it, drops down 2, and it goes up to infinity. So the dropping it down 2 changes your output just by a little bit. Anyway, that's a run through. I hope you enjoy it. Get some work done, and we'll talk to you when you have questions. Don't be afraid to email or ask